Here's our lesson for today. It's going to be patterns in tables. So today we're going to be seeing different tables, and we have to notice what kind of patterns are going on in these tables. So very important that we know what kind of patterns we're looking for, and we're going to go over those real quick. So there's two different types of patterns that we're going to see. The first one's called an additive pattern. So an additive pattern is pretty much what it sounds like. We are going to see addition going on. So basically in an additive pattern, and I highlighted the word add so we know, hey, we're looking for addition in this pattern. It's a number that is added to the x coordinate. I think I spelled that wrong. No, I didn't. To result in the y coordinate in an ordered pair. So our patterns are going to be dealing with x coordinates and y coordinates. That's why we're saying we're going to add a number to our x coordinate, and it's going to give us our y coordinate. Okay, our other kind of pattern we're looking for is called a multiplicative pattern. And I'm going to underline the word multiplicative. Well, I guess kind of the multiply in that word, right? So maybe I'll underline to the I, or I'll highlight to the I. And this one is what it sounds like as well. This one means that there's multiplication going on. So in a multiplicative pattern, a number is multiplied with the x coordinate, and this number, when these numbers are multiplied, they will result in the y coordinate of an ordered pair. Now, whenever you're looking for these patterns in these tables, it's important that the pattern, you understand that the pattern has to stay the same for it to be a pattern. So what I mean by that is, if you're looking at one single table, the pattern to get from one part of the table to the other part should always stay the same. Meaning if we're adding a number, we're going to add every time. If we're multiplying a number, we're going to multiply all the way, or multiply all the way down. This is very similar. If you, in fourth grade, you may have done something called an input-output table. This is very similar. We're going to input a number. We're going to apply a rule to it, either an addition rule, that's an additive pattern, or a multiplicative rule, that's a multiplication pattern. And then we're going to get an output. The x is your input. So let's make a little note of that. Let's label both of these because some of you may have remembered this from fourth grade. So x is the input. It's what we're kind of putting into our input machine. And then once we input that, we're going to apply some rule to it, and we're going to, it's going to shoot out a y. That's our output. Okay, so let's go ahead and look at a couple examples, okay? So right here we have a table. So again, all about today is looking at tables and trying to find the patterns that are going on in the table. Okay, so we have number of seconds. This is your x coordinate or your x value. We have 1, 2, 3, 4 down. And then number of beats. This is our y coordinate or our y value. This is 70, 140, 210, 280. So we want to figure out what pattern's going on here. How do I get from 1 to 70? 2 to 140, 3 to 210, and 4 to 280. Remember, there's a pattern here. And this pattern has to work every time. So we get our input, which is 1, and we need to apply our rule, and we'll get our output, which is 70. And then we're going to do the same thing. We have 2 as our input. We need to apply our rule, or our pattern, and we need to get our output. And this needs to work all the way down. Our rule that we're setting needs to work all the way down, because it's a pattern. This would not be called a pattern if we're doing something different the whole time, right? So we need to kind of think, what can I do with 1 to get to 70? Could I add a number? Sure, I could add 69, but then that rule's got to be done all the way down. Well, 2 plus 69 is not 140, so that rule must not work if you're kind of following along. My rule has to work every time. Every input and output has to follow the same rule every time. So are you able to find the rule? What are we doing with 1 to get 70 and 2 to get 140 and so on? Well, we are multiplying. So that makes our rule multiplicative. And the pattern I see is we're multiplying by 70. 1 times 70 is 70. 2 times 70 is 140. 3 times 70 is 110, and 4 times 70 is 280. So my pattern works all the way down. So that is the pattern for this table. It's a multiplicative relationship, and we're multiplying by 70. So really, I'm following this rule. X, whatever X is, times 70 is going to equal Y. Now, we have a fancy way of writing this as a pattern. So when I write this as a pattern, I'm always going to start with Y. My Y value equals my X value times 70. So I could say it like this. X times, I'm going to use a dot because if I had two X's in a row, it may be kind of tricky, times 70. So we always lead with the Y first when we write our patterns because we just start with our answer. So whatever Y is, it's the X coordinate times 70. So for instance, 70 equals 1 times 70. 140 equals 2 times 70. 210 equals 3 times 70. And so this pattern follows this table. Now, there's actually a better way to write this. We can still say we still start with our Y equals when we write the pattern. Instead of X times 70, you're going to see it a lot of times like this. 70X. So let's make a note real quick. I'm going to highlight it and make a note. When a number touches a variable, it means multiply. So another way to see multiplication, I know we saw that a lot in PIMDAS, all these extra ways to see multiplication. This is another way you got to recognize multiplication. When a number is touching a variable, it means that they're being multiplied. So really our pattern in this table is Y equals 70X or Y equals 70 times X. Okay. All right, let's go ahead and do the next one. So we can see our tables where the X and Y are in columns like this. We can also see where they're horizontal, so they're side to side. So the X is on top and the Y is on bottom. Okay, and it's always going to follow that. X is always going to come first, X is always going to be on top, Y is always going to come second, Y is always going to be on the bottom. So the first thing we want to do is figure out what is my pattern? What pattern is going on to get from X to Y? What am I doing? What's my input? What's my output? What's my rule that I am following? And remember, this rule has to work the whole time. So I can't just look at 1 times 6 and say 1 times 6 is 6. That's my rule times 6. That's my pattern in this table. That's not true because times 6 doesn't work the whole time. What math am I actually doing? Well, 1 plus 6, maybe I'm adding. What would I be adding? Plus 5? Does that work the whole time? 2 plus 5 is 7. 3 plus 5 is 8. 4 plus 9 is 5. Or 4 plus 5 is 9. Oh yeah, my pattern of plus 5 works. That's my pattern. This is my pattern for my table. Plus 5. I would check every single X or input and output you have. Does plus 5 work the whole time? Yes, it does. If it doesn't, then that's not your pattern. Okay, so what am I doing here? I'm taking my X value, which is the week, how many weeks, and I add 5 to it, and it gives me my Y value. So we need to write that. Well, first we can say it's an additive pattern because we're adding. Now I need to write that as a pattern. Okay, well, to write as a pattern, we're going to write Y equals. And then what am I doing to my X? I'm adding 5 to whatever X is. X plus 5. And luckily, addition, we don't have an extra way to write it. You do just write an addition sign. Whereas the multiplication, we can write it as the number touching the variable to show multiplication. All right, the last one. So we have a pattern. Again, we have a table. We got to recognize a pattern. We got to be able to pick or write the pattern for Y as Y equals whatever the pattern is and choose whether it's adding or multiplying. So the first thing I would do is my table, I would label it the X and Y. X always comes first and then Y, just like the alphabet, just like your coordinate plane in your ordered pairs, X and then Y. Okay, and I have time and distance, and I have my inputs, which are my x's, my output, which are my y's, and I need to figure out which rule works the whole way down. I like drawing these arrows just so I am making sure I follow every single one of them. Okay, 0 to 0. Well, that's a lot of things, right? Because 0 plus 0 is 0. 0 times any number is 0. So this one's not really too helpful, right? Let's go 2 to 6. Okay, I can do plus 4. I can do times 3. Let's see which one of those works. 4 times what? Or 4 4 plus 4 is not 12, which that was what I was maybe thinking because 2 plus 4 is 6. But 4 times 3 is 12, and 6 times 3 is 18. So does times 3 work the whole way down? Times 3? 0 times 3 is 0. 2 times 3 is 6. 4 times 3 is 12. 6 times 3 is 18. Very good. So we can see this is a multiplicative pattern because there's multiplication going on. And then we also want to be able to write this as a pattern. Well, what's a pattern? Well, we always start with our y, and we know we're multiplying our x by 3. So I'm going to say y equals, oh, that's a bad y. Y equals, remember we always start our pattern, our equation out with y equals, and then we just write what's happening to our x value. 3 is being multiplied by x. Well, we have a way to write that. 3x. Remember, we made our note earlier. When a number touches a variable, it means multiply. So we have 3x here, and that just really means 3 times x. Whatever x is, it's being multiplied by 3, and it gets us our y. That's our pattern. Okay, that's going to go ahead and be your lesson for today. Make sure you go ahead and try to get your practice done. Turn that in, and let me know if you have any questions about anything.